Hello and good morning, everyone. I welcome you all to India's largest e-learning platform, Unacademy. And I welcome you all to my session of Capacitors and Inductors Part 2. And I welcome you all on behalf of the GATE Conqueror channel and the team. It's a very important session, extension of yesterday's one, Capacitors and Inductors. Useful for both GATE and engineering services. Ask all of your friends to join very soon, dear. It's going to be a very important session for you. Before we move in, let me introduce myself. I'm GC Reddy, secured AAR 1931. I work as motivation speaker, expert in EMFT, communications, advanced in communications, microwave engineering, antennas, and digital circuits. Fine. This is an official Telegram channel for the GATE Conqueror team. Official Telegram channel for the GATE Conqueror team. You can access the entire team through this particular Telegram channel, including the legendary K.N. Rao sir. Unacademy provides you two important paid platforms. One is the Plus subscription, the other is an iconic subscription. In Plus subscription, you got to have the FaceTime of legendary faculties in the form of live classes. You'll have weekly tests for regular practice, structured courses for good and systematic learning. You have unlimited access for all the batches. You'll have rank improvement batches included in it, as well as some crash courses. All of them in Plus subscription. You need not take a separate subscription again. In Plus subscription itself, you can also go for rank improvement and crash courses. So that's advantage of having this Plus subscription. And if you're going for an iconic subscription, you'll get all the features of a Plus subscription, and you'll be assigned a personal coach for one-on-one guidance for your strategic preparation. And also, you'll be having dedicated doubt clearing educators to clear your doubt then and there. And you'll also be provided a customized study planner to track your performance. And you'll be having study booster sessions like regular workshops where you receive some essential guidelines. And also, most importantly, we'll also do the personalized test analysis. If after the test is done, we'll give you a customized report of this particular analysis. Along with that, we'll also provide you with special notes and practice sets for your practice purpose. All this in iconic subscription. Basing on the requirement, either you can go for Plus subscription or an iconic subscription. In both the cases, you can avail no cost EMI. What is a no cost EMI, dear? No cost EMI is nothing but total cost of the subscription will be divided by number of months without adding any extra cost. So this is the best for students who can take the subscription right away and start your preparation at a very low cost. For example, you want to take a Plus subscription for 12 months. You need not pay 32,450. Rather, you can pay 2,704 and start your subscription. This is after you use my code GCR10, where you get an extra 10% off. Similarly, you can do it with Iconic subscription also. Instead of paying 56,450, you need to pay just 4,704 and you can start your preparation, because this particular EMI we got by dividing the total cost by number of months. Therefore, no extra cost. That's what it's called the no cost EMI. Remember to use the code GCR10 to avail extra 10% off. As you all know, we are into the EMF full comprehensive course and we're done with Maxwell equations. For static fields, these are broad lines I'm giving you broadly which topics we are done. Good morning, Rasul. Thank you. Broadly, I'm trying to explain which topics we had covered. The full comprehensive course we had completed. The Maxwell equations for static fields, which includes Gauss law, conservative property of electric field, Ampere's law, and Gauss law for magnetic field or non-existence of magnetic monopole. We also completed Maxwell equations. Yes, Anil, good morning, dear. Maxwell equations for time varying fields. What is the difference between static fields and time varying fields? Two equations will vary in time varying fields. The conservative property of electric field is varied because only static electric field is conservative. It is irrotational but not time varying electric field. In time varying electric field, the spatial orientation of electric field is equal to the time varying magnetic field, which is given by Faraday's law. And Ampere's law is only consistent for static fields. It fail or it is inconsistent for time varying fields. So we understand the inconsistency of Ampere's law, which is modified by Maxwell, also called as Maxwell contribution, where the term JD, displacement current density, is added, which by completing Faraday's law and Maxwell contribution will complete Maxwell equations for time varying fields. This was also completed. Chakravarti, good morning, dear. This was also completed by us. We completed Poisson's and Laplace equation. Boundary value problem it is also called. We have done numerics on this also. Enough number of practice problems are also done on these concepts. And also we have completed boundary conditions. For four Maxwell equations, we have derived four boundary conditions. For dielectric boundary conditions and dielectric conductor boundary conditions. The previous class we had seen the formulas for capacitors and inductors, and we have derived the derivation for parallel plate capacitor and coaxial capacitor or capacitance of a coaxial cable. Today we'll move further and derive the capacitance of a spherical capacitor and also the inductance of coaxial cable. And we'll also try to see some numericals where we'll see the applications of this capacitors and inductors. Is that clear? Very good, very good, very good. Nice. So far we have done this. So let me give a quick review what we had completed in the previous classes. Then we'll move forward. Is that clear? Very good. Very quick review we'll give. We had seen the formulas for parallel plate capacitor. The capacitance of a parallel plate capacitor is given by C is equal to epsilon A by D. Where D is the distance between the plates. Epsilon is the dielectric that is placed between the plates. A is the area of each plate. The capacitance is given by epsilon A by D. If you replace that dielectric material with free space, good morning Pavan, good morning Raj, Ravindra, good morning. If you replace that with free space, epsilon A by D, if you do C by C naught, gives you epsilon by epsilon naught, which is epsilon R. This we are derived for the parallel plate capacitor. If you consider a solenoid of length D, N is number of turns, then for the solenoid, inductance is given by N square mu A by D, where D is the length of the solenoid. Good morning everyone. Fine. Now, if you replace mu by mu naught, N square mu naught A by D, L by L naught is mu by mu naught, which is mu R. Similarly, if you go for coaxial cable, capacitance is given by 2 pi epsilon L by ln of B by A, where L is the length of the coaxial cable, L is the length of the coaxial cable, A is the radius of the inner conductor, and B is the radius of the outer conductor. Epsilon is the dielectric constant of the dielectric material. Then the capacitance of the coaxial cable is given by 2 pi epsilon L by ln of B by A. Similarly, the inductance is given by mu L by 2 pi into ln of B by A. That's capacitance and inductance. And if you consider a spherical capacitor, in a spherical capacitor, you have two spheres, one of radius A, other of radius B, separated by a dielectric. epsilon. This forms a spherical capacitor. One is carrying the positive charge, the other is carrying the negative charge. It forms a spherical capacitor. The capacitance of a spherical capacitor is given by 4 pi epsilon 1 by A minus 1 by B. Similarly, if you go for a toroid, if you're going for a toroid, when you go for a toroid, this is a toroid, radius R, this is a toroid, radius R. You see here, magnetic field intensity is given by Ni by D. B is given by mu times of Ni by D. B is mu H. Here in the toroid, inductance is given by N square mu A by 2 pi R. N square mu A by 2 pi R. H is Ni by 2 pi R. And B is mu times Ni by 2 pi R. Energy stored here is half CV square and I is equal to C into dV by dt. Energy stored here is half Li square V is equal to L into di by dt. These are the formulas and the procedure to find capacitance. Choose a suitable coordinate system. Let there are two plates. Plate 1 carrying charge plus Q. Plate 2 carrying charge minus Q. Separated by dielectric with dielectric constant epsilon. There must be a flow of electric field between this positive charge and negative charge, and they are separated by some distance. Therefore, it results in formation of a capacitor. The procedure includes, now what we try to do is, We apply either Coulomb's law or Gauss law to find electric field intensity. Once you got this, then we substitute V is equal to minus line integral of E dot dl. From this you'll get V value. It's 2 to 1 E dot dl. Then you apply the formula C is equal to Q by V. From this you'll try to derive the capacitance value, which already we had seen in previous class also. Am I right? So now already we had seen the previous class. We'll find the capacitance of a parallel plate capacitor. For that, let me consider parallel plate capacitor with its plates placed along the x-axis as shown in the figure. The two plates over here is at 0, the other is at D. That means they are separated by distance D. This is plate 1. This is plate 2. Plate 1 carrying the positive charge and plate 2 carrying the negative charge minus Q. Separated by dielectric with dielectric constant epsilon. Electric field moving from positive to negative. This unit vector along x-axis AX. Direction of electric field along minus AX. Is that clear? This we have seen. Now if you consider a single plate carrying surface charge density, a single plate carrying surface charge density rho s, electric field is given by rho s by 2 epsilon of An. Here rho s charge is Q. Here rho s is total charge by total surface area. Let charge carried is Q and surface area of each of the plate is S. Rho s is replaced by Q by S. Now it's a parallel plate capacitor. Already we had seen in Coulomb's law also, special case. It's a parallel plate capacitor. So in parallel plate capacitor, what we do? The total electric field is the sum of these two plates. Rho s by 2 epsilon An plus the other one is carrying minus rho s by 2 epsilon. Normal is minus An. Minus or minus is plus. So electric field for parallel plate capacitor is rho s by epsilon An. If rho s is Q by S, Q by epsilon S of An. Here An is the direction of electric field, which is minus Ax. An is minus Ax. Minus Ax. This is E value you got. Now by substituting V is equal to minus integral 2 to 1 E dot dl minus integral the second plate that 0 first plate at D 0 to D E value Q by epsilon S minus of minus plus Q by epsilon S Ax dot dl is dx Ax. It's Q by epsilon S integral of 1 dx, which is x, limit 0 to D. V is QD by epsilon S. Capacitance is Q by V. Therefore, Q by QD by epsilon S. Capacitance is epsilon S by D. S is nothing but surface area. This gives you the capacitance of a parallel plate capacitor. C is equal to epsilon A by D. In circuit theory, what we do, dear? Yes, Bhaskar, good morning, dear. In circuit theory, what we do? For a parallel plate capacitor, the capacitance is directly proportional to the area of the plates and is inversely proportional to the distance between them. Capacitance is proportional to A by D. Capacitance is equal to epsilon A by D. That's it. This is from circuit theory. The same concept I am using field theory concept. Is that clear? Yes. Bhupati, Bhaskar, Pavan, everyone. Is that clear? This is for the parallel plate capacitor. Next, for a coaxial cable, coaxial cable is having inner conductor of radius A the coaxial cable is having inner conductor of radius A and outer conductor of radius B, which is of length L. And these conductors are separated by dielectric with dielectric constant epsilon. We want to find the capacitance here. Procedure: choose a suitable coordinate system. Here the coordinate system is cylindrical coordinate system. Take two plates, plate 1 and plate 2. Plate 1 carrying the positive charge and plate 2 carrying the negative charge. Yes, done. Plate 1 carrying positive charge and plate 2 carrying the negative charge. Apply Coulomb's law or Gauss law. Very easily, it is symmetric surface, therefore you can apply Gauss law to find electric field intensity. We need to apply Gauss law for the Gaussian surface. Which is of radius rho. Gaussian surface which is of radius rho. A less than or equal to rho less than or equal to B. Gaussian surface will have a radius between A and B. Apply Gauss law. According to Gauss law, psi E is equal to charge enclosed. Psi E is the flux cut by this Gaussian surface. given by closed surface integral of d dot ds is equal to charge enclosed by this red cylinder is total inner conductor. Inner conductor is carrying a charge of plus q. Closed surface integral d dot ds is equal to q. D is d rho a rho, because this is rho. The one that is coming out of this is a rho. D is d rho a rho, and ds is cylindrical coordinate system. Coordinates rho phi z, normal a rho, length along phi rho d phi, length along z dz. Therefore, ds is rho d phi dz a rho. From this d dot ds is d dot ds is d rho d phi dz. Surface integral of d dot ds is d rho double integral d phi dz. Phi running from 0 to 2 pi, z running from 0 to L. This is d rho integral of 1 d phi, phi 0 to 2 pi, 2 pi. Integral of 1 dz, z 0 to L. That's L. So this is d rho into 2 pi rho L. Either you can do this complete procedure, or simply after this step, you can write d rho outside. Closed surface integral of ds is the lateral surface area of the cylinder of radius rho and length L, which is 2 pi rho L. Done. Is the best way to verify your answer. Is equal to RHS charge enclosed. D rho is Q by 2 pi rho L. D is D rho A rho. D is Q by 2 pi rho L A rho. Now once you got this D, how much you got? Q by 2 pi rho L A rho. D is epsilon E. Is Q by 2 pi rho L A rho. So this is Q by 2 pi epsilon rho L A rho. Once you got the V value, E value, find the V value. V is minus integral 2 to 1 E dot dl. Why take not rectangular coordinate system? Cylinders we are evaluating, Bhaskar. Here we are evaluating cylinder. That's why cylindrical coordinate system. In the previous one, we had evaluated between the plates, therefore rectangular. Is that clear? V is minus integral 2 to 1 E dot dl. Okay. Just let me know. Is that clear? Therefore, V is equal to minus integral this first plate, this second plate, 2 to 1, that is B to A, E dot dl is Q by 2 pi epsilon rho L. A rho dot dl is D rho A rho. A rho dot A rho is 1. V is equal to minus q by 2 pi epsilon L integral B to A 1 by rho d rho is minus 2 pi epsilon L integral 1 by rho ln of rho B to A multiplying minus inside. This is q by 2 pi epsilon L ln of rho A to B, reversing the limits by multiplying minus inside. This q by 2 pi epsilon L ln of B minus ln of A, upper limit minus lower limit. V is q by 2 pi epsilon L ln of B by A. That's V value. Capacitance is equal to q by V. q by 2 pi epsilon L into ln of B by A. Capacitance is 2 pi epsilon L by ln of B by A. Capacitance for a coaxial cable. Capacitance for a coaxial cable. Is that clear? Next, we'll go for a spherical capacitor. To form a spherical capacitor, we need two spheres. One of radius A and the other of radius B. And the other of radius B. One is of radius A, other is of radius B, separated by dielectric with dielectric constant epsilon. These are the two spheres. Inner sphere, outer sphere. Forming a spherical capacitor. Which coordinate system, Bhupati? Bhaskar, which coordinate system? Tell me. We'll choose a spherical coordinate system. We'll choose spherical coordinate system. Am I right? Because we are handling with spheres. Inner conductor is carrying charge Q plus Q. Outer is carrying minus Q. Separated by dielectric constant epsilon. Apply Gauss law. We need to consider a Gaussian surface of radius rho such that this rho is in between A and B. Because we are handling with spheres, let me call it as R. Gaussian surface of radius R When R is between A and B. Consider this Gaussian surface. Apply Gauss law. Psi E is equal to charge enclosed. Psi E is the flux cut by the Gaussian surface. Charge enclosed is the charge enclosed by this Gaussian surface. How much charge this Gaussian surface is enclosing here? The Gaussian surface is enclosing the complete inner cylinder or the inner sphere. The inner sphere is carrying charge plus Q. Therefore, charge enclosed is Q here. If psi E is equal to Q, psi E is closed surface integral of d dot ds is equal to Q. Implies D is equal to, if this is R, the one that is going out of this is AR. If D is equal to dr AR, ds spherical coordinate system coordinates are theta phi, normal AR, length along theta R into d theta, length along phi R sin theta d phi. If a ds is R into R square sin theta d phi AR, d dot ds dr AR dot R square sin theta d phi. You got d dot ds. Surface integral of d dot ds is AR dot AR is 1 dr R square double integral sin theta d phi. Theta running from 0 to pi, phi running from 0 to 2 pi. This implies dr into R square integral of 1 d phi, phi 0 to 2 pi, 2 pi integral of sin theta minus cos theta 0 to pi, that is cos theta pi to 0. Dr into R square 2 pi cos 0 1 minus cos pi minus 1 1 minus of minus 1 1 plus 1 2 is equal to RHS charge enclosed. This implies this is dr into 4 pi R square is equal to Q. After this step, directly you can write this. How? Write dr outside, closed surface integral of ds is surface area of the sphere of radius r 4 pi R square. If you understand this, this is procedure. Every time try to understand procedure. Don't go for shortcut. Anyways, for cross verification in examination, it will be useful in GATE. In engineering services, you should know the complete procedure also. Clear? What you got? dr into 4 pi R square is equal to Q. Implies dr is Q by 4 pi R square. D is dr AR. D is Q by 4 pi R square AR. D is epsilon E. Epsilon E is Q by 4 pi R square AR. Is Q by 4 pi epsilon R square of AR. You got E. Try to find V value from this. V is equal to minus line integral 2 to 1 E dot dl minus line integral B to A is Q by 4 pi epsilon R square AR dot dl is dr AR. dl is dr AR. AR dot AR is 1. V is minus integral B to A Q by 4 pi epsilon R square dr. V is minus Q by 4 pi epsilon integral B to A 1 by R square of dr. R power minus 2 integral R power minus 2 plus 1 by minus 2 plus 1 minus 1 by R minus of minus plus Q by 4 pi epsilon of 1 by R, it is B to A. V is Q by 4 pi epsilon 1 by A minus 1 by B. Capacitance C is Q by V, Q by 4 pi epsilon 1 by A minus 1 by B. Q and Q get cancelled. I'll write it properly here, dear. Q by 4 pi epsilon into 1 by A minus 1 by B. Capacitance is 4 pi epsilon by 1 by A minus 1 by B. Capacitance of a spherical capacitor. With inner radius A, outer radius B. Good morning, Anandi Meena. Almost we are completing the playlist, everyone here. Bhaskar, Anandi Meena, Pavan, everyone. We are almost completing the playlist now. Around 55 hour. We are expecting full-length comprehensive course playlist of EMF. This will be like never before. Everything about EMF will be covered in this particular playlist. All the concepts will be covered. Almost now we took around 40 hours. This is like lecture number 38. More probably practice questions, engineering services derivations. Put together, we can expect 10 more sessions, which will complete the CMF. And this particular playlist will be a wonderful playlist, which will be useful for all the exams, especially for AAA people. This is going to be useful like anything, because we covered everything here. It will be useful for GATE, ESE, practice questions, previous year questions, whatnot. We covered everything here. So that's for the spherical capacitor. For the spherical capacitor, the capacitance is 4 pi epsilon by 1 by A minus 1 by B. Now in this spherical capacitor, if you make this B the radius of the outer capacitor to infinity, then as this is moving forward, there is a separation between the inner sphere and the outer sphere. When B tends to infinity, the inner sphere will become isolated. Therefore, when B is tending to infinity, the inner sphere is called isolated sphere. The inner sphere will become isolated sphere. The capacitance of such isolated sphere is C is equal to 4 pi epsilon by 1 by A minus 1 by infinity. 1 by A minus 0. The capacitance of an isolated sphere of radius A is 4 pi epsilon A. Please share this playlist among the maximum, dear. In this playlist, whatnot, everything will be covered. This will be very much useful for all the students, including faculties. So with this, all the three capacitance we are done. Spherical capacitor, coaxial cable, and the parallel plate capacitor. And remember, dear, in some of the exams is asking about fringing. And can anyone throw light on fringing? What is fringing? Anyone? If anyone can throw light on fringing, we'll have a discussion on that. Fringing. If you consider a parallel plate, capacitor, one plate is carrying the positive charge, other is carrying the negative charge, separated by distance d. Then what is fringing? There will be flow of electric field, positive charge to negative charge. Positive charge being the source of electric field, negative charge being the sink of electric field. Okay, loss of electric field is fringing. Very good, Bhaskar. Very good, very good. So what is fringing is, if you consider the area of each plate is A, if you consider area of each plate is A, then when these two plates are largely separated, or D is large value, when D is a large value or separation between the plates is larger, when the plates are not close enough, this is the area of each plate A, and there is a spacing between them. If the plates are like this, spacing is very large when compared to area. When D is far, far greater than A, that's the meaning. Then, because they are farly placed, there will be a non-uniform distribution of electric field on the corners. This effect is called fringing. And if you want to avoid fringing, you need to keep the plates very close enough to each other. Therefore, fringing will be avoided. Is that clear? Yes. Everyone, is that clear? So that's about fringing. And we had completed parallel plate capacitor also. So we're done with parallel plate capacitor. We derived this. We derived this for coaxial cable. We derived this for spherical capacitor. Now, we'll also derive the inductance of a coaxial cable. Solenoids, toroids also will deal in the later sessions. Don't worry. In today's session, we'll also derive the inductance of a coaxial cable. The inductance of a coaxial cable. Which equation? Okay, Bhaskar. Tell me which equation? For fringing, there is no equation, dear. Fringing means non-uniform distribution of electric field around the corner of the plates when the plates are separated by larger distance. This is area of each plate. This area. This is distance between the plates, D. If they are very largely placed like this, to form a capacitance, we need two plates. One carrying the positive charge, other carrying the negative charge, separated by distance D. Separated by distance D. When this distance is very large, there will be non-uniform distribution of electric field on the corners. This non-uniform distribution of electric field on the corners of the plate is called fringing. If you want to avoid fringing, bring the plates closer. Bring the plates closer. Now distance is very small when compared to area. Then this non-uniform distribution across the corners will be avoided. When D is far greater than A, fringing will occur. If you want to avoid fringing, bring the plates close enough. Bring the plates close enough. Is that clear? Yes, dear. Now you tell me. Is that clear? Are you asking something else or was your doubt the same? I hope I had cleared your doubt. Please let me know. In a parallel plate capacitor, when the plates are far away, there will be non-uniform distribution around the corners. To avoid the non-uniform distribution around the corners, you must bring the plates closer. Clear? We'll go for inductance of a coaxial cable. Inductance of a coaxial cable. Consider a coaxial cable, inner conductor of radius A, outer conductor of radius B, outer conductor of radius B. Okay, inner conductor of radius A and outer conductor of radius B separated by dielectric epsilon. This cable is having a length L. we know that capacitance of the coaxial cable is 2 pi epsilon L by ln of B by A. Already we have derived this. Now I want to derive the inductance, which is mu L by 2 pi into ln of B by A. How derive? How to derive the inductance here? What's the procedure to derive the inductance here? Is there anyone? Bhaskar? Anyone? This inner conductor, to this inner conductor, this is current I passing. Magnetic field intensity H is given by I by 2 pi rho A phi. I by 2 pi rho A phi. Okay. Then B is mu H. B is mu I by 2 pi rho A phi. From this, you know, psi m, surface integral of B dot ds. Surface integral of E dot ds. B is mu I by 2 pi rho A phi. I want ds. Cylindrical coordinate system. Coordinates rho phi z. Normal A rho. Length along rho. D rho. Length along z. dz. Of direction A phi. Therefore, ds is d rho dz A phi. Implies B dot ds is mu I by 2 pi rho A phi dot d rho dz A phi. This is mu I by 2 pi rho d rho dz. Surface integral of B dot ds is mu I by 2 pi integral rho integral z dz. What is rho here? Anyone? Limit of rho. The limit of rho. Please let me know. Bhaskar. Anyone, please let me know. The chat box updating. Please respond to chat box. Limit of rho. Rho. Between B, it is between A and B. Rho is between A and B. Z is 0 to L. Length of the cylinder. Mu I by 2 pi. Mu I by 2 pi. This is 1 by rho, okay? Integral 1 by rho d rho. ln of rho. Limits A to B. Integral of 1 dz z. Limit 0 to L. Mu I by 2 pi. ln of B minus ln of A. Integral 0 to L. L minus 0 L. Mu I by 2 pi. ln of B by A into L. This is surface integral of B dot ds. which is psi m. We got psi m is this value. I want inductance. Inductance L is equal to lambda by I. Lambda is flux linkage, N psi m. Because we are considered state conductor, N is 1. For a state conductor, L is psi m by I. Psi m you got it as mu IL by 2 pi ln of B by A. Psi m by I. By I. I and I get cancelled. L is mu L by 2 pi into ln of B by A. That's the inductance of a coaxial cable. Mu L by 2 pi into ln of B by A. Mu L by 2 pi into ln of B by A. Derived. Done. Is it clear? So we're done with the derivations related to parallel plate capacitor, coaxial cable, spherical capacitor. We found the capacitance for these three cases. And we got the inductance of coaxial cable. Clear? Any doubts you can ask dear. Any doubts you can please ask. Anyone, any doubt you can ask dear. But we are finished so far. So far, any doubts you can ask. Now you know we are done with these things. Derivation, capacitance of parallel plate capacitor, capacitance of coaxial cable, capacitance of a spherical capacitor, inductance of a coaxial cable. We can also do one thing. We can find inductance of a solenoid. Any guess how to find inductance of a solenoid? If you consider a solenoid, how to find the inductance of a solenoid? Inductance of a solenoid. L is equal to lambda by I. Lambda is flux linkage. N psi m by I. N psi m by I. Psi m surface integral of B dot ds or B into S, surface area. If A is treated to be surface area, you will write as B into A. B is mu H into A. H is inductance of a solenoid, Ni by A, or you can say Ni by L. Ni by L length, sorry, Ni by L. Average length is, let it be D, so Ni by D. It is Ni by D. Inductance L is equal to lambda by I. Lambda is n psi m, so n psi m by I. Psi m is surface integral of B dot ds, B into S or B into A. B is mu H into A. H is Ni by D. Therefore, psi m is mu N I into A by D. Substituting N into N square mu I A by I into D. I and I get cancelled. Inductance of a solenoid L is equal to N square times of mu A by D. Is it clear? Yes. Is it clear? Why I am specifically explaining, because people ask me why n square, sir, why not n? That's why I am giving the derivation for this. Okay. Now we have done inductance of solenoid also. So let me consider this problem. A coaxial cable of inner radius 1 mm and outer radius 5 mm. Inner radius 1 mm, outer radius 5 mm, as capacitance per unit length of 172 picofarad per meter. Capacitance of a coaxial cable 2 pi epsilon L by ln of B by A. But I am having C by L here, farad per meter. Therefore, C by L is 2 pi epsilon ln of B by A. 2 pi epsilon by ln of B by A. For 2 pi epsilon by ln of B by A is given as 172 picofarad per meter. The ratio of outer radius to inner radius is doubled. Now B by A, present B by A is 5 by 1. This ratio is doubled, means it became 10 by 1. If the ratio is doubled, then the capacitance per unit length C2 by L is asking. So C1 by L is 2 pi epsilon ln of B1 by A1, which is 172 picofarad per meter. C2 by L is asking, which is 2 pi epsilon by ln of B2 by A2. This is what is asking. If you do C2 by C1, C2 by L by C1 by L, then it is 2 pi epsilon if you do C2 by C1, then it is 2 pi epsilon ln of B2 by A2 by 2 pi epsilon ln of B1 by A1. This is C2 by C1 ln of B1 by A1, ln of B2 by A2, C2 by C1, ln of B1 by A1, ratio of B1 by A1 is 5. 5 by 1, ln of 5 by ln of 10. C2 is ln of 5 by ln of 10 of C1, 172. Tell me the answer. Find the answer and tell me fast. I'm also calculating, okay? Calculate and tell me. Not log ln. Not log ln. Not log ln. Yes, Vishnu, good morning. Not log ln. Log to base C. Base C. Bhaskar, base C. Calculate and tell me the answer. Log will take base 10 because it is operated on decimal number system. The numbers will have 10 characters, 0 to 9. That's why base 10. ln is natural logarithm. It will take base E. It will take base E. For all scientific approach, we go for natural logarithm. One 20. Okay. This value approximately 120 picofarad per meter. That's your answer. It's a previous year question on coaxial cables. Previous year question on coaxial cables. Clear? Next, all this. Good. Very good, Bhaskar. If you are going for digital concept, V is log to base 2. For all general calculation, to base 10. For calculations, you go for base E, ln or base E. Base E is for calculating any value. Base 2 is for digital calculation. And base 10 is for general analog calculations. Try to solve this. A soft iron is concentric with long straight conductor carrying DC current of I. Current is I. If the relative permeability is mu r, the short iron, which is 100, the ratio of magnetic flux density at two adjacent points located just inside and just outside of toroid is magnetic field intensity of toroid. B is equal to mu times Ni by 2 pi r inside the toroid. Outside the toroid, mu naught times Ni by 2 pi r. I want ratio just inside and just outside. Means B by B naught. Mu Ni by 2 pi r by mu naught Ni by 2 pi r. B by B naught is mu by mu naught. Mu is mu naught into mu r by mu naught. The value of B by B naught is mu r. Given mu r is 100. For the ratio value is 100. Your answer is 100. Clear? No dear, complete theory. Complete theory. Mahamarathon is complete theory. From basics to complete theory, Bhaskar. We had completed all the basics. Radiation pattern, radiation mechanism, current carrying capacity, gain, directivity, all the theory, all the 7 antennas, folded dipole, its construction, its design, applications. In similar way for all the antennas, Yagi-Uda, construction, theory, construction, applications, helical, microstrip, parabolic reflector, lens, and horn antennas. And also we went for V, inverted V, rhombic antennas, complete theory and design, plus applications, and also practice problems. We had completed. Previous year questions will start from tomorrow. Is that clear? Okay. This problem is done. Rest of the practice problems we'll do in the next class. There is an important announcement that I need to make today. Just listen carefully. This is for the live mentoring. If you are going for an iconic subscription, if you go for iconic subscription, you get 1:1 mentoring. Increases your chances of getting a top rank. You can use the code GCR10 to avail extra 10% off. To avail extra 10% off, you can use my code GCR10. Iconic subscription is a very special subscription because you get a personal mentor to guide you. Your chances will improve like anything. This is an offer, 3+1 offer. With 3 months subscription, you get a 1 month subscription free. Those who are preparing on your own up to now, I'll give you a very good idea, because when you are getting 3 months subscription, you will get access to full videos anyways, but only for 3 months. But already those who are preparing on their own, so many students are preparing on their own, just they can go through in this 3 months, they can go through the lectures of India's topmost faculty for GATE and ESE in this 3 plus 1 4 months, so that whatever they are revised now, they can improve on that, they can build on that in a strong way through these lectures. So for those people who are targeting GATE and ESE 2022, this subscription will help you out in scoring a very good rank. There will be a small gap that you need to fill, that can be filled by faculty very easily, such that you get a top rank. The rank which was previously 5,000 now can become 500. This 5,000 to 500 journey that can be done through this subscription. We are targeting GATE and ESE 2022. Those are targeting GATE and ESE 2022 and they are looking for 2023 also, then this subscription will be useful for them. Already they might have been prepared. Now they can build on this 12-month subscription plus 3 months. So the subscription will be valid up to GATE and ESE 2023. And the good thing is you can get an avail extra 10% off also. That is, you can get this subscription only for 29,205. For 29,205, you'll get 15-month subscription and it will be valid up to GATE and ESE 2023 also. And in this 15-month span, you can prepare for any competitive exam in between. So that's the advantage there. This is the best and ideal time to take this subscription also. And if you are having financial problem in taking the subscription, Unacademy is providing you, if you are having the metal, if you are having that knowledge, then attend this particular combat for sure. 28 November 11 a.m. Sunday 11 a.m. 20 questions only. 60 minutes will be given. It is for mechanical, civil, ECE, electrical and CSID. The top 200 people will get around scholarship of 4 crores. First 3 people will get 100% scholarship. First 3 ranks. 4 to 10, 75% discount. 11 to 50, 50% discount. And 51 to 100, 25% discount. 101 to 200, 15% discount. And lucky draw 500 participants will stand a chance to win all these gifts. This is a free initiative. You need not pay anything. Just use my code GCR10 and try your luck. You need not pay anything. You'll get the subscription for free. Inform this among your friends also, dear. These are the special class features. Yeah, interactive live classes, polls for the learners, raise a hand option. You never miss a class once you follow the profile. After the class, you can download the lecture notes. You can access anytime and anywhere. Unacademy has recently introduced a feature called Ask a Doubt, through which it can ask unlimited number of doubts and get them clarified. So you need not wander here and there to clear your doubts there. All of your doubts will be cleared on our app. This is a new batch, Arrow 1 GATE and ESE 2023 for ECE Explained Bilingual, started 17th of November. This is Arrow 1 GATE and ESE 2023 for GATE and ESE 2023 aspirants for Electrical Explained Bilingual, started 17th of November. These are the new batches for GATE and ESE across all the branches, which are all started on 17th of November. And these are modules where we are targeting GATE and ESE 2022 particular subjects, which are started yesterday, 24th of November. And this is modules for GATE and ESE 2022. ECE Explained Bilingual. We are targeting specific subjects. And these are modules and the new batches like Verb, Arohan, Rank Improvement modules and all. Each one of them started yesterday, 24th of November. You can use my code GCR10 irrespective of your branch. You can use my code GCR10 to avail extra 10% off. This is where you can follow me on Unacademy app. Take a screenshot and share among your friends here so that your friends will also join us. Thank you all. Thank you all for your patient listening. A big thank you from Unacademy. Big thank you from the GATE Conqueror team. Big thank you from our leader, K.N. Rausa. And I want to tell you that we people will stand with you always. And all the students who want to learn in English, this will be a single stop solution for you. We will be here to help you out. Join us on Telegram. Express your difficulties that you have. Express what help is required for you. We are ready to support you people even on Telegram. So keep an association with us. We want to be a part of your success story, especially from South India, those who want to learn in English, and the complete India, all those who want to learn in English. We will stand with you. We are ready to stand with you. We'll take the pain for your success. Thank you all, dear. Have a good day.